to Jan Hein. Now we'll see if it works this time. Thumbs up for working? Great.
Yes.
So, as Jan Hein said, welcome first of all to the race to the root cause. Woo! So, I'm Klaas van Schelven and I'm the solo founder of BugSync. And so, BugSync is error tracking. What does it mean? Error tracking is you have some code running somewhere, right? You have some real thing that you care about, it's running somewhere, and then it goes boom, you have an exception, and you have an error, and an error tracker then collects as much information as possible about that error. So that's, for example, your stack trace, code context. I should show it a little bit. Don't worry, the ad will be over soon. Code context, the values of all your local variables, and it collects all that stuff, it sends it to a central location, the information gets grouped and made insightful to you as a developer, and then you go, now I understand what I did wrong, and you fix the error, and everyone goes home happily and lives happily ever after. So that's great. But as I said, advertising my company is not the only goal of this presentation. So why is this even relevant at all? Well, this means that because I'm doing this stuff, I'm collecting a lot of errors and collect a lot of stack traces. So I'm kind of forced to think about what is the stack trace anyway? Why is this particular, for example, Python stack trace confusing me so much? What could I do to make it less confusing to the people that use my program? So because of all this stuff, I've made this collection of interesting stack traces, and then I had them on my shelf, and I thought maybe I can do a talk about that. So that's how we got here. So by the way, it's either I collect all these interesting stack traces because I have this company, or of course it's the other way around. I have this genetic predisposition to love stack traces. This is just how I was born, and then because of this fact, I started this company. That's the other option. It doesn't really matter for us. What matters is we have now a nice collection of stack traces, and we're going to see them. So a little bit of housekeeping. Let's do a show of hands. What is it? Is it a stack trace or a traceback? Show of hands for stack trace. And show of hands for traceback. Slightly less, which is surprising because the right answer, of course, is that both of these words exist. Traceback is the word that we Python developers all use because the Python stack trace is inverted, right? From the perspective of all the other languages, the Python people have the stack trace in the exact other order, where the most recent call is last. And then you call it a traceback. And I always call it a stack trace, so this kind of betrays the fact that I'm a polyglot, or it betrays my age and that I had other languages before I came to the one true love, which is Python. So a couple more housekeeping things. I have no idea how smart you all are, what your level of experience is. So I'm just going to try to have exactly the right level. And if it's too hard for you, then you'll come away at least with some kind of learning of, oh, that's an interesting language feature that I didn't know about yet. And if it's too easy for you, this is also possible, then you have to remember that I kind of distilled all these examples down to the true essence and the true core, which is great for learning. But don't think, oh, that's just a trivial example, I'm so smart. No, you have to remember that I did all that work for you so that you get a great example, and then when you see it in the wild, it won't be trivial, because then it will be an extra thing to confuse you on top of the actual problem that you're solving, which is the fact that you or one of your colleagues already made a mistake and blew up your already complex, because we're all dealing with complex problems, already complex program in an interesting way. And then you also have the extra thing where the stack trace is messed up. So this is going to be an interactive talk, so if you like the sight of me standing up, you're out of luck. If you like slides, you're also out of luck, because this is not a slide, and it's also whatever it is, it's the last of it. It's a website, and now we're going into code. And I think I had all the housekeeping solved. So now we can, that's great, because we spent 5 minutes doing housekeeping, now we have 25 minutes of interesting examples. So before we start with the actual interesting examples, let's start, and I'll actually sit down as I said. Let's start with the baseline, because if we have a baseline, then we all know, first of all, did I mention I love stack traces yet? I love stack traces. So we have to kind of establish, I'm going to show you all the horrible examples of stack traces, right? And then you will come away and think, that man really hates stack traces. Is the hater of Python. This is like, he's doing like making Python sound like JavaScript. That's not what I'm about. So I want to show you that in the good case, stack trace is awesome, and we should all love stack traces. And even despite that, when we have interesting language features, as we do in Python, we will also have interesting stack traces, which can confuse us. So let's do the baseline, and then I can take a sip of water while you all puzzle it out. So simple. So what does this mean? Now I'll take my sip of water. This is also the practicing round, right? So you're all, who knows what this is? What's going on here?
An exception happened.
Okay, yes, an exception happened. Yeah, so, okay. Let's do the standing up after all. So, yeah, so it's a stack trace or a traceback. So it says most recent call last. So this tells us, we start reading at the bottom and we see, oh, okay, an error happened. It happened in this simple POC line 10 in a thing called base. How the hell did we end up in base? Oh, we were on line 6. The same file in a function called bar. It called base. And then before that we were in a function called foo, and that's called bar, and etc. Right? So that's the game we're going to play today. I hope the next rounds you guys are even going to be even more involved and interactive in doing the shout out on what's going on. But the other point is, right, you would do this exercise, you would do this puzzle in real life also, but you wouldn't do it as a puzzle. It would just be immediately obvious to you, but you would do it to achieve some other goal. You're trying to debug an actual application. And this tells you, how did we get to the point in time where everything went horribly wrong, right? So that's the game, and you can also, I know why you didn't, I wouldn't do more advertising. It was too hard for you because you saw it in an ugly way, right? But you can also just run it like this and get this super cool looking same thing, and it's immediately obvious to you, oh, okay, I see the code context, we go up the stack, super easy. So this is what we're going to do. That was the last simple example. I have one that's slightly less simple, and what is it? It's the with statement. So do we all know what the with statement is? Great. Well, for the 3 people that didn't raise their hands because they are afraid to come out as people that don't know what, let's do how is your eyesight? Can we all see this? Can we read this? Yeah. Great. Yeah. So what's the idea? I'm not going to talk about the implementation because that's the boring part and it would give the game away also. So, but the idea is you have 2 things that go together. You have some kind of resource, a context it's called here, and you want to do something else in the context of this resource. So it could be, for example, opening a file, and then when you're done, you have to close that file. And this awesome syntax helps you doing that. It kind of automatically does the things that go before first, and then after, whether you go there by an exception or whatever, it always does the closing thing. So, what's the next step? Let's show a stack trace. See which one I have to do. Probably POC. So what's going on here? And most importantly, maybe I should show it right side by side. Can we do that? We're still here? Yeah. So it's a with statement, POC. So, POC. So my biggest question to you as the audience here is, what are we doing on line 13 of the function that fails?
Entering.
Entering?
Init.
Context.
Entering the context.
Init the context.
So someone says leaving. Yeah, so thanks for the plant in the audience. you will get your 10 euros later. So this is exactly, and also applause to the people that said leaving the context, because of course the right answer here is we are leaving the context. But we can only know this if we read on past this line that I highlighted to confuse you. So here it says exit, and exit is of course a tell that we are inside something that is leaving the context. And of course, if we look here, we can also see that is exactly what your instructor put there to make it do what the instructor thought was necessary. But yeah, so I think this is a confusing example because you're kind of led to this point in the code which is before other code, and you think you are before that other code. But Python, when it executes, it goes first, it enters this thing, or first it initializes it, then it enters into this thing, then it executes this code, and then it comes back here. And this is actually the only case in Python where you have this order. So you're kind of put on the wrong foot. First of all, because it's the only location in Python where you have this kind of awesome syntax. I think actually part of the reason is because this abstraction is so awesome, so you think it's like it's just this thing that always works. It opens and closes things for me and you never think about it again. But what really happens is that it kind of puts things before and after, and then you never think you might end up after. And finally, the real reason, of course, is the missing syntax. You all know the hidden syntax of Python, right? We know this syntax. Do you know what this syntax means? No, you're good Python people. Applause, you don't even know what brackets are anymore. Like so deeply into Python. So this is the Python bracket syntax, and if it was a real thing, then your exception could point at line 20 instead of line 13, because it could kind of guide you to the place where it actually went boom. So, what's next? That was another easy example. We'll see how far we go now. What's more confusing?
Well, if you look at the stack trace, then now since a couple of versions, the line from stack gets underlined.
Yeah, you're right. Yeah, I'm going to finish your sentence to save my time, but yeah, the underlining is wronger than wrong. So it says, it underlines these brackets, but there's no reason for, I think that's just a bug. There's really no reason for it to point at the brackets, because if the brackets would mean anything, it would be the init, right? And not the enter or the exit. So I think it's just a bug, which goes into the Q&A. You all 200 people together posting this bug to the CPython. Will be easily the most important thing in Python. So delegation is the next example. We'll do code first. Let's see how it goes. How fast I can do this. So what is delegation? Well, you might do, it's another way to compose programs than doing inheritance, and I'm going to go very quickly through this setup here. The idea is that you get some object from some other context that you don't control, and you might want to decorate it. You might want to add some extra feature to this object so you can pass it back into a location. Let me zoom in. You can, so you can use it in another context. And what you would do is say, I have this Java compatible list, and for any attribute that I don't have on the actual list, I'm just going to delegate to the thing that's being passed to me, and then init is just the setup of your thing. So you just store the delegate, and then of course you have this kind of unholy thing here, which is adding the size property to a Python list. And now we're going to run this code. I'm just going to assume everyone is up to speed here. I'm just going to run the code and say, what does it do? Well, this is too hard because now it's two things at once. So here, what does it say? List has no attribute size. And who can explain to me why this is? Faces. Yes, a hand in the back.
Is that a special character in len which is causing entry error?
Yes. So there's an evil thing that I did. Great spot. So, but the follow-up question is, okay, so there was an evil thing there, right? It said just a non-existing thing. But why doesn't it say why does it say list has no attribute size? Why doesn't it point at list, or actually more like Java compatible, or rather it should actually be list in this case because it's the delegate that is being tried here. Why doesn't it say your delegate doesn't have len with ugly character? What's size doing here? A hand? Yes. You have to speak up.
Oh, get error and sexual exception.
Yes, yeah, I will count this as correct. So, so yeah, here it says get attr is only called if the attribute wasn't found in the usual way. And what it actually checks, it's a shorthand for, it checks that there is an attribute error either when you access the origin, like the Java compatible thing. So if you would say Java compatible len, which Java compatible of itself doesn't have, then it would go there because it doesn't have it, and then try that again on the delegate. But it also does that when this is a property. So this is kind of the evil thing. When there is a property and the property dunder get thing also raises an attribute error, then it goes back and tries it with the same thing that you originally tried on the delegate. What's the percentage of people that are still on board? Okay, that's great. That's great. So that's delegation and attributes, and let's do next something I call the puzzle. So here my notes say that I should do this. So what's going on here? What does it even mean? What's going on? It's trivial. Yeah. So I will refine my question a little bit. What's the? We see two exceptions, right? One is raised during the handling of the above exception. So my question, to make it a little bit more precise and actionable, is how did we end up in line 15 of this show something function?
Try accept.
It's the second one in the accept block of try accept?
Yes. Yeah. So this happens to be correct. So what this is I'll show you actually some code. It's easier. What are we doing? Puzzle. Yeah. So here's the code, and we called show something, and then we raised an original exception. Then can we do this side by side? Works for me, but I have to stand somewhere else. We show exception, we raise this original exception, that gets caught, and then inside the handling mechanism we raise another exception, right? Of course, this is the trivial example, because it's only like literally lines of code that are actual lines of code. I think it's 8 or 9. Except for the definition of the exceptions themselves. So what's really kind of missing, if you go here, is that you see two exceptions, but one of these exceptions, kind of the path to this exception, has been taken out. So you no longer see how do we get at show something. How did we get this line 15? Well, you kind of have to do this thing in your head where you take this bit and put it above the other one and reason about that all in your head. And this is because Python, in all their wisdom, have chosen to kind of deduplicate all the information. So all the information that exists in both these exceptions, they take out of the first exception and only show it in the final exception. And I personally think this is like making things more hard than it's absolutely necessary. And in fact, just because someone was so quick to say like it's easy, I can show you that it's even possible to come up with kind of these evil examples. Let's fit it a little bit more. Where you can have two different paths to generate the same exception. So whether you use the top one or the bottom one, they have the same, they show up the same way in your stack trace, but what actually happened was a different thing. So in the, help me out here, so in the top one you call in finally, so you first go to finally, nothing happens in the first thing, then you recurse, and then you raise it in the try, and then again you raise it in the finally. And in the other one you do something else, and it shows up in exactly the same way. So if you're proud of yourself that you can spot the other thing, it's just by luck, right? You can't always know it. So let's do a final one. I know Jan Hein is very strict on time. So let's do generator for maximum complexity. So we all know what generators are? Okay, great. That's already a great start. So then I'm just going to do a very short introduction of what this thing is. So we invert control flow. So we have this thing, the request fetcher, and we send URLs to it, and then we try to get those URLs. And if that doesn't really work out, okay, too bad. And then we have the main loop, and the main loop is where the control actually takes place. So we send to the thing that fetches the URL, we send the URLs. So, drum roll. What's wrong with this code? You already knew it, right? You saw the code and you knew what was wrong. Maybe we can present it like this. Who knows what this means? A hand? Yes.
Well, I've seen it before.
Excellent answer. Something wrong with the That's right. That's the correct answer. Yeah, go ahead.
So you're trying to exit the program. Then Python will send the generator exit to the generator, but you have a try except, a bare except, and it will stay in the true loop. And then it will just ignore it, and Python will have to kill it, and then it will say this was a runtime error. Right?
This is indeed the correct answer. It contains most of the parts. I will try to just repeat it in slow motion by pointing at the code. So yeah, I typed exit here, right? So you can type exit as to hit this thing, and then you will try to leave that loop. And then what happens is you hit your garbage collector. So at some point your garbage gets collected when this main exits, and at the moment the garbage gets collected, Python sends this special generator exit to this generator. But because this is a bare accept, the generator exit is also caught. So this is why you should never do it like this, but always do it something like this, and then it's no longer as bare, so you no longer catch your keyboard errors and your generator exits and your system exits. And because this is a while, you would loop back to this point, and then you would yield again, and that's caught. That's set by Python, like you can't do this. But if you were, for example, it's Q&A time. I've agreed with Jan Hein to just completely use up my Q&A time because we're already talking with you awesome people. So, yeah, if you were kind of not as brilliant as Sebastian and just saw this and thought, oh, that's easy, let me think, catch it, what's it called? Just catch it, right? It's easy. So we saw an error, and we saw here it says main, right? So why don't we just do try except around the main, and then try to go into the debugger. That doesn't work. It's evil. There is a way. You can ask me later how to catch it after all, but it's still the exact same problem. So it's like more head scratching. What else can I show you about this? Should have.
Never do bare accepts.
Sorry?
Never do bare accepts.
Never do bare accept is definitely a takeaway, and then if you already have that takeaway, so like some people think, oh, that means that this is also bare, but this, oops, it's wrong. Yeah. So this is enough already to solve the problem, right? Here you're catching everything that's meant to be caught. Another answer here could be just close your generator. If you're already going into generator land, you might as well call it close yourself rather than rely on the garbage collector. This also makes it much easier to figure out what's going on. Yeah, actually, the final thing I wanted to show you here is like even or I could just do this generator. Like even the whole idea that we started off with, that so this is the bits, this is the bit we're looking at now. The whole idea that your stack trace actually contains your stack is no longer true if you're in this kind of exceptions that happen during garbage collection world. So this is main itself is called, but how we got at not main is completely not obvious in this case. So that's the last piece of puzzlement I want to leave you guys with. I had many more, but you'll have to invite me again if you like this kind of stuff, and then I can do more examples. But they were all just the bonus examples, right? You never missed anything that you were meant to not miss. So thank you very much for your attention, and I was really glad about the good answers also.
Yeah.